हेलो एवरीवन, वेलकम टू माय चैनल फिजिक्स टिक्स। सो आज हम कुछ प्रॉब्लम्स करते हैं बेस्ड ऑन फ्लूइड मैकेनिक्स एंड दैट इज दिस इज द फर्स्ट प्रॉब्लम। द थ्री वेसल्स शोन हैव सेम बेस एरिया, equal volumes of liquid are poured in three vessels. The force on the base will be. So we have three vessels over here. One is like this. They gave this. Other one is like this, and other one, the last one is like this. The base area will be same. So if we pour the equal volumes of liquid, so that means if let us consider this is the liquid. Now if I pour this as height, let us consider H2, right? Now if I pour this volume over here, same volume over here, obviously the height of this will be lesser. Why? Because some part of the liquid, height of this will be lesser than this, and height of this will be greater than this. Why? Because some part of this is the liquid, right? This is the liquid which is at the same height, but some part of the liquid will occupy over here in this area, so the height will be lesser. So this height we can say H1. Now if I pour over here, now the liquid will be like this, isn't it? Same height. So this part will go up, isn't it? Like this, and we have the height of third vessel will be the greatest. So we have H3 is greater than H2 is greater than H1, isn't it? So as H3 is greater than H2 is greater than H1, and as we know pressure is directly proportional to H, so as height increases, as depth increases, you can say the pressure increases. So H3 is greatest, so pressure at this point will be the greatest, so P3 is greater than P2 is greater than P1. So if I multiply by area, base area, so we will get the force on base, and that is P3A is greater than P2A is greater than P1A. So we can say force on third vessel on the base will be greater than force on second vessel, which is greater than force on first vessel. And this is the answer. So this is question में देखो. The next question is the three vessels shown have same base area. Like these are the three identical containers given. Equal masses of liquid are poured in three vessels. Equal masses are poured. That means mass of A is equal to the mass of B is equal to the mass of C. The force on the base will be, and given that rho A is less than rho B is less than rho C. So mass, we know mass is nothing but density into volume, density into area into height, you can say. Now as masses are same, so and the area is also same, so rho into H will be constant. So we can say rho A into HA is equal to constant. Likewise rho B into HB is equal to constant, and rho C into HC is equal to constant. ठीक है, तो अब देखो that is height is inversely proportional to rho. So rho जिसका कम होगा उसकी हाइट ज्यादा होगी, तो रो A is lesser than रो B and रो C. So that's why जिसका रो कम होगा उसकी हाइट ज्यादा होगी. That means यहाँ पर जो हाइट होगी इसकी ये सबसे ज्यादा होगी. HA की हाइट ज्यादा, उसके बाद HB की हाइट होगी, एंड उसके बाद HC की हाइट होगी. बस ये याद रखना है आपको कि हाइट ज्यादा उसी की होगी जिसकी डेंसिटी कम होगी. अब यहाँ पर पता है हमको प्रेशर जो होता है वो डायरेक्टली प्रोपोर्शनल टू हाइट होता है, तो HA is greater than HB is greater than HC. तो हम बोल सकते हैं कि जो प्रेशर होगा A का वो ज्यादा होगा B से, और वो ज्यादा होगा C से, और एरिया से मल्टीप्लाई कर देंगे तो हमको मिल जाएगा फोर्स ज्यादा होगा B से और वो ज्यादा होगा C से. ये होता है इसका solution. A barometer kept in an elevator reads 76 centimeter when it is at rest. If elevator goes up with increasing speed, that means elevator is accelerating upward, the reading will be, the reading we have to calculate. So see here, the setup is like this. This is the elevator. In this one barometer is placed, supposed to be this is the barometer. Now this lift is moving upward with an acceleration a, right? So whatever the effective g is there, g effective will be equal to, we know that g plus a, right? So whatever the pressure is there, pressure, that is the atmospheric pressure, is equal to, we have rho g h when this elevator is at rest. Elevator is not accelerating, you can say, right? This is the expression when elevator is not accelerating. Now whenever this elevator is accelerating upward with an acceleration a, so whatever the g effective, how this g effective will become g plus a, we can see simply by using this. This is the normal, this is the mg, and this is the ma force accelerating upward supposed to be. So the greater force will be normal and the mg will be lower, so that's why it is n minus mg, which is equal to ma, and from this you will get n by m, and that is the effective, which is equal to g plus a, and this is the effective acceleration. So if you put this value over here, rho g plus a into h dash, right? H dash. Why h dash? I'll let you know. Okay, see here. Now this P naught is equal to rho g h. P naught is atmospheric pressure, and this will remain constant. As rho g is equal to constant, this g effective into h must be constant. So if g effective into h must be constant, as one value increases, as g increases, you can see h must decrease. So whatever the reading shown by the barometer is, which is lesser than 76 centimeter. Why? Because if one value increases, here as you can see clearly, g increases, g effective increases, h must decrease, and initially it is 76 centimeter, finally it must be lesser than 76 centimeter. Now this is the solution to this question. If next question is given, a barometer kept in an elevator reads 76 centimeter when it is at rest, same. If elevator goes down with increasing speed, the reading will be. Now in that case, here only g minus a will be there. As g minus a decreases, h dash must be, h must be increases, and in that case, reading must be greater than 76 centimeter. Now the next question is, the surface of water in water tank on a top of house is 4 meter above the tap level. Find the pressure of water at tap level. So situation is like this. Okay, so here we have a tap, suppose. Okay, and this water level is at 4 meter. Now we have to find out the pressure at this point, and as we know, pressure will be constant on a horizontal level. So on a trap level, the pressure will be constant. तो pressure यहाँ पर कितना होगा? ये pressure जो होगा वो होगा, that is equal to P naught plus rho g h, right? So this is the absolute pressure. So as they are asking about the pressure, only about the gauge pressure, so we have P minus P naught, and that is equal to the gauge pressure, and that is equal to rho g h. Now rho of water will be 1000 into g, we can consider 10, and h given 4, so we got here 40,000 Pascal is the answer. And one more thing, this tap must be closed. If this tap is open, the level of water will decrease and this pressure, the gauge pressure, will not be constant, that is 40,000 pascal. So it is necessary to mention that the tap is closed.